The human ability to design and invent has changed the world in a relatively short time. Less than 10 generations since the invention of the Watt steam engine in the 18th century, which led to the Industrial Revolution. Since then, the number of inventions and designs artifacts has exploded to create the current technology-based world and the overall much higher standard of living for a population of about 7 to 8 billion in the 21st century. That is about 10 times larger than that of the pre-industrial revolution. In the late 19th century and the 20th century, the design of internal combustion engines created the automotive industry and the oil industry that dominated the world's economy for more than a century. The jet engines, introduced in the mid-20th century, shrunk the world. People can travel anywhere in the world in about 24 hours. In the 21st century, semiconductors and advances in telecommunications have revolutionized all aspects of human lives. The advances in biotechnology are also improving the quality of life of many and are likely to create a new era of human history. All this progress has been possible because of the human ability to design, inspired by challenging goals and promising ideas. Our ability to design creatively is likely to determine humanity's future. There are many challenges. We need to grow the economy, producing goods and services to improve the quality of life, all while improving the environment. We also have to combat various old and new diseases through the design of better drugs and healthcare systems. The advances that have enriched and improved the quality of life have also created new challenges for humanity in the form of global warming and others, which must be addressed during the next few decades. The animal husbandry that has satisfied the human need for protein intakes of people is likely to be replaced by proteins derived from vegetables, partly related to human attempt to solve global warming problems and health issues. Solutions to all these issues depend on our ability to design. What is design? Design refers to a set of creative activities to satisfy human and societal needs and goals through synthesis. Design is motivated and driven by three basic elements of human nature: inspiration, curiosity, and necessity to improve the quality of life through creation of something new and better. Sometimes these three factors reinforce each other. Regardless of the motivating factor that initiates the design thinking and activity, the first thing the designer must do is to establish goals of the design task. Then, the designer must identify the problem that must be overcome to reach the design goals. And finally, the designer must create useful and meaningful solutions to the problem identified. Design and creativity have a symbiotic relationship. The ability to design generates creative solutions. Conversely, creative minds yield unique and appropriate designs. Axiomatic design theory enhances the probability of strengthening the symbiotic relationship to create solutions that are better than random trial and error processes. Axiomatic design, or AD, provides a theoretical foundation for the creation of imaginative and optimum designs that satisfy the desired functional requirements, FRS, that the design must fulfill to solve the identified problem. The ability to state the FRS is a foundation for modern technologies on various non-technological systems. The design is a series of transformational processes. It could be a routine process or an inspirational process of creating new ideas and solutions. Briefly, it begins with the design goals. In the customer domain, we define the problem we must address to achieve the design goals. After the problem is established, we create a set of functional requirements that we must satisfy to solve the problem identified. Then, we transform the functional requirements to design parameters, followed by the transformation of design parameters to process variables. Depending on the nature of the system to be developed, design parameters and process variables take on specific physical, informational, biological, and organizational entities. The transformational process of going from problem definition to functional requirements, design parameters, and process variables follows the same methods regardless of the specific nature of the design task. All of them must satisfy the independence axiom and the information axiom. When we complete the design, the resulting embodiment is a collection of design parameters that constitute a system or product. We must check for physical compatibility, information flow, biological functions, and safe operations, among others, to assemble the final system. To find an appropriate design parameter for a given functional requirement, or the right process variable for the chosen design parameter, we must depend on the fundamental laws, principles, and known phenomena of science, engineering, and other relevant fields. The quality of the design thinking and ideas depend on the designer's understanding of natural laws and principles, as well as human aspirations, needs, and limitations. In scientific and technological fields, the relationship between functional requirements and design parameters is often governed by natural laws, which may require mathematical modeling to predict the outcome. In general, the uncoupled design simplifies and enables the fulfillment of design goals. We can make right design decisions based on our understanding of design principles, natural laws, and the human needs. Through the design process, we must seek inspirations to generate designs that are most imaginative, appropriate, and creative for the task identified or defined. Ultimately, through creative and rational designs, we advance the lot of humanity and even the natural world. What sets humans apart from other creatures is creativity and their ability to conceive and create solutions through design. For instance, generation of solutions that have not existed hitherto through synthesis. It has taken many centuries to cultivate this human creativity. Until about 6,000 to 8,000 years ago, human beings lived in the Stone Age. Eventually, the Stone Age ended, not because humans ran out of stones, but they had found something better, iron. Thus, the new Iron Age was born. However, the subsequent advances in technology and science were slow. They had to wait many tens of centuries for science and modern technologies to emerge. In the mid-17th century, people like Isaac Newton began to lay the foundation for science, and another 100 years later, inventors like James Watt started to create new technologies that led to the Industrial Revolution. Then, a new era for humanity has begun, accelerating the transformation of the world through the use of human brains. What humans have created in basic knowledge and technologies during the past 3 centuries is most impressive. Furthermore, the rate of new advances and innovation has been accelerating ever since, which has challenged many aspects of human and societal assumptions and practices.